I wanted to talk about Newton's third law, which is weird in that almost any adult can quote it at you. For every action, there's an equal and opposite reaction. But I would say almost none of those people understand it. A much better way to say Newton's third law is that forces come in pairs, and that the pair of forces is identical, it's on two different objects, and it's opposite in direction. And furthermore, the agent and victim get switched. So what do I mean by that? Let me give you an example. So I got this table here. I'm going to punch it. We could say Dowd punched the table. But because of Newton's third law, we also have to say something else. The table punched Dowd. And that's a weird sentence to say. And it sounds kind of awkward, but it's the reason that my hand kind of hurts. There's no force that you can describe that you can't switch the thing causing it and the thing being affected. And if you start thinking about it, it starts getting weird. For example, you know that things fall down because of gravity. In fact, you know there's a force of gravity on me right now. So you could say the Earth is pulling Mr. Dowd. Do the Newton's third law pair. Does that mean Mr. Dowd is pulling the Earth? Yeah, it does. Did you see the Earth fall up towards me? It did. Just a little bit, though. If you look on the board behind me, you'll see the math that describes why the Earth didn't move that much, but I moved a lot. There's a better picture of this elsewhere in the Flickr album. But basically, the force on me falling and the force on the Earth falling were the same. So that's why it says Fg Earth, which is what's acting on me, and Fg Dowd, which is what's acting on the Earth. It says they're the same. But since I'm so much less massive, I accelerated a lot more. The Earth, of course, accelerated incredibly small amount. But it did. And Newton's third law is something to keep in mind is true for all forces. Every force has a pair. I wanted to finish with one other demonstration with these spring scales. They look kind of fancy, but inside here there's just the spring like the other spring scales you've seen. And to be honest, they're not that good. I've got one here on the pole, and I'm going to hold the other one. And I'm going to pull on the pole. So this spring scale will register how much the pole is pulling on me. This one will register how much I'm pulling on the pole. Of course, according to Newton's third law, they have to be the same. And we see that they are. Now, it's not perfect because they're kind of cruddy spring scales, but they do move together, and they always have approximately the same reading. So this ought to help describe the tension force and where you draw the force arrows for the tension force. So there's going to be a force picture or a free body diagram on the next slide. But what I really want you to see here is that Dowd pulls the pole pulls Dowd, and they're always about the same.